Okay, here we are on page 8. We're going to do everything with points and lines. So let's start. Find the slope between the following sets of points. Now, slope, you'll remember, has that formula where you take the y's and subtract them over the x's and subtract them, and we get a ratio, a number, ratio of rise to run that represents the steepness. So here we go. The slope here is going to be the 5 minus 0 over 3 minus 2, 5 over 1, or 5. Number 2, slope is going to be 2/3 minus 2/3 is 0, over 0 minus minus 3 is 3, 0 over 3 is 0. This is going to be a horizontal line. Number 3, we have the slope is going to be -7 minus a minus 3, that's minus 4, over -6 minus 2 is a -8. So this one simplifies to 1/2. Number 4, 7/5 minus 0. Ooh, we may need to write this guy down. It looks like we're going to get a little bit of fraction here. 7/5 minus 0 is 7/5, and all over 1/3 minus 1/3 is 0. Oh, you can't divide by 0. Don't do that. This guy is undefined, or this is a vertical line. X equals 1/3. The next one, 6 minus minus 1, that's 7. 4 minus 5 is a -1, so we get a -7 slope here. And the final one, 4 minus 5 is -1, and 6 minus 2/3. This is 18/3 minus 2/3 is 16/3. 1 divided by 16/3 is the same as 1 times 3/16. So -3/16 is the slope on number 6. Good. Number 7. Notice that here we're trying to find the midpoint, and the midpoint is exactly what it entails. You take the middle of the x's, the middle of the y's, and you are right in the middle of the 2 points. So it's the same thing we had up here, but now we're finding the middle of them. So 5 plus 0 divided by 2 is 5/2, or 2.5. 3 plus 2 is 5, divided by 2 is 5/2. So 5/2 is right in the middle of those 2 points. Let's try this one. 2/3 plus 2/3 divided by 2/3, well, yeah, that's going to be 2/3. And -3 plus 0 is -3, divided by 2 is -3/2. Good. Number 9. Ooh, -7 plus a -3, that's -10. Divided by 2 is a -5. -6 plus 2 plus 2 is -4. Divided by 2 is -2, so -2/5. Again, this is what I'm doing. I'm taking the x1 plus the x2 all divided by 2, and the y1 plus the y2 all divided by 2. And notice it's very different. Slope up here, we subtracted them to find the distance between them, and these we add and divide by 2 to get the arithmetic mean. All right, number 10. 0 plus 7/5 divided by 2 would be 7/10, and 1/3 plus 1/3 is 2/3 divided by 2 is 1/3 again. Number 11, 6 plus a -1 is 5 divided by 2, 5/2, or 2.5. 4 plus 5 is 9 divided by 2 is 9/2. Now I keep doing the y's first just because I got in that habit up here with slope, but you could do them in any order. And the last one, 4 plus 5 is 9 divided by 2. And 6 plus 2/3, again, this is 18/3 plus 2/3 is 20/3, divided by 2 is 10/3. Good. Now we're going to find the distance between the following sets of points. And you'll notice we're using the same sets of points, and we just need to make sure we do this. Now, something about distance really fast that we should make sure we understand. When you have this point and this point, and you're trying to find that distance, there is a cool looking formula that says distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. And you're like, hey, I've seen those before. Yes, this same thing up here, and I know some textbooks do y2 minus y1, and that's fine. You can do it either way. But right here, these guys, you're just finding the same numbers that you did with slope up here, and you are putting them in a right triangle and using a squared plus b squared equals c squared, or in this case d squared, and then we square root it. So I will refer to it just as a Pythagorean triple and use these numbers that we already have up here. So here we have the distance here is 5 and the distance here is 1. So 5 squared plus 1 squared, that's 26, square root. So we're doing a squared plus b squared equals c squared. On this one, 2/3 to 2/3 is 0, and 0 to 3 is 3. 0 to negative 3 is 3, so we have 0 and 3. 0 squared plus 3 squared equals what squared? Well, it's going to be 3. Number 15. Here we have a distance of 4, and here we have a distance of 8. And so 4 squared plus 8 squared equals c squared. So this is 16 plus 64. That's 80 equals c squared. So we're going to do the square root of 80. Does that simplify? Yeah, it does. There's a 4 that goes into it. Ooh, 80 is 4 times 20. Oh, there's another 4 that comes into it. 4 times 4 times 5. So what's the square root of 4 times 4? That's 4 square roots of 5. So that's the distance on number 15. Let's write that in here, 4 square roots of 5. Okay, number 16, 1/3, that's a distance of 0, and that guy is a distance of 7/5. Well, 0 squared plus 7/5 squared is 7/5 squared. Square root is 7/5. Well, yeah, it's on a vertical line. We're just going straight from 0 up to 7/5. All right, on this one, we have a distance of 7, and we have a distance of 9. A squared plus b squared equals c squared. This is 81 plus 63. This is 81 plus 49. 81 plus 49 is 130. Square root of 130. Can that go down at all? That's 2 times 65. Yeah, I don't think so. Square root of 130. And the final one, we get the distance here is 9, and the distance here is, 18 16/3. So we got 16, this may take a little bit of work, 16/3 squared plus 9 squared equals this distance squared. So we get 81 plus 256 ninths equals d squared. 81, that would be 729 ninths plus 256 ninths. That equals, yuck, that's starting to get pretty big. This is 985 ninths. And now we're going to square root that to get d. So we get the square root of 985 all over 3. That's our distance. Whoa! Square root of 985 all over 3. Let's check and see if square root of 985 can go down at all. 5 and 197. Yeah, I'm not seeing a perfect square come out of that, so I guess we're good. Square root of 985 over 3. That one looks kind of weird. All right, let's erase a little bit of this and see if we can get some space on these next ones. On 19 through 24, we've got write the equations of the following lines. Now, writing the equations of them, there are 3 ways to write it. And the most common one you'll notice is y equals mx plus b, where m is the slope and b is the intercept. This is called the slope-intercept. There's also another one called standard form, and it's ax plus by equals c. And in this case, note that the slope is the opposite of a over b. If you haven't become familiar with this one, this is a very handy tool in writing equations of lines. And then there's another one called point slope form, where you actually have a point x1, y1, and you put it in like this, where there's a slope, and then the y and the x stay as loose variables, and the y1 and the x1 are actual points that you put in. So I'm going to move around and sometimes use this one, and sometimes use that one, sometimes use that one, and so I'll try to keep it a little bit separated as to when I'm using them, but we'll use all 3 of them so you can see it. Okay, number 19, parallel to 2x plus 3y equals 7. Well, the easiest way is that we're going to have number 19. Let's put this guy right here. Number 19, well, 2x plus 3y, that's going to give you the exact same slope, a slope of negative 2/3. And it goes through this point, negative 6, 3. So if we stick negative 6 in for x, that gives us and 3 in for y. This gives us negative 12 plus 9 is a negative 3, and there's the equation. Let's also do that one, number 19 over here, where you have y minus 3, the y value, equals slope negative 2/3 x minus a minus 6. So either one of these would work, and we could have done it, put a 2/3 in there and then stuck the point in to solve for b, but these are go a little bit easier. But both of these can be solved into the y equals mx plus b, the slope-intercept form. Let's do number 20 now. Number 20, parallel to y equals negative 3/4 x minus 7. So I'm going to do this one over here, 20. Parallel to y equals negative 3/4, that means we're going to use that same slope, y equals negative 3/4 x, and we don't know what b is yet, but we know that if we stick in negative 2 for y and 3/4 times 5, we can find the b. So this is negative 15/4. So if we add 15/4 over here, then this is negative 8/4 plus 15/4 is 7/4 equals b. So let's erase that guy right there. Yeah. And then we have plus 7/4. Good. There's your y equals mx plus b example for you. Number 21, perpendicular to 5x minus 2y equals 77. Notice this one has the slope of 5/2. So we would need to go perpendicular to it. So we want the slope on number 21. We've got to have the slope as a negative 2/5. So if we were to use this one, we'd say y plus 6 equals negative 2/5 x plus 2. And that's the slope, the point slope form. This one, the standard form, would look like this: 2x plus 5y equals, and then we would stick in negative 2, negative 6, and see what number pops out. Negative 4 minus 30 is a negative 34. There we go. All right, number 22. Perpendicular to y equals 5/7 x. So this is, we want slope instead of 5/7, we want the slope on number 22. We want it to be slope is a negative 7/5, so we have a perpendicular slope. So we do y minus 1 equals negative 7/5 x minus 7. And then of course if you jumped it through, you could see what would go on here. You'd have y minus 1 equals negative 7/5 x plus 49/5. Now if we add 1 over here, add 5/5, we get y equals negative 7/5 x plus 54/5. And notice that this is not necessary if they have the answers written in point slope form, but notice that I just wrote it in this form over here, slope intercept form. Cool. Number 23. 23 is perpendicular to x plus 6y equals 6. So this one has slope of negative 1/6. And you may have to practice that. I'm actually using this shortcut right here, but you can solve for y, subtract x, and then divide by 6 to get into this form if that's easier for you to see. Slope is negative 1/6, so we want perpendicular to it. We've got to have slope of 6 over 1. So I'm going to do a slope of 6 over 1 right here, and I'm going to write it 6x minus y equals, and then stick in the point 4, negative 6. 6 times 4 is 24, minus a minus 6 is 30. And there we go. Notice we could have also done that very easily with this form or the other form. And number 24, parallel to x plus 6y equals 4. So that just lends itself to, look, x plus 6y. That means we have the exact same slope. Now we stick in 5 and 1, and it's 5 plus 6 is 11. And there we have it. We could rewrite this one. Let's do this one in point slope form. This slope is negative 1/6. So it would be y minus 1 equals negative 1/6 x minus 5. And you could leave it like that if that's how the answers are written, or if you did slope intercept, you could either solve this for y, well, minus x, and divide by 6, and you get negative 1/6 x plus 11/6. And notice what would happen over here. So here I just solved this one for y. And this guy right here, if I jumped it in, I get y minus 1 equals negative 1/6 x plus 5/6. And now if I add 1 over here, I'm going to add 6/6. So I get y equals negative 1/6 x plus 11/6. Oh my goodness, math is true. No matter what you do, you will get it right. On 25 through 30, we have a little bit of a trick going on here. We've got to find the perpendicular bisector. So we have to find the slope and the midpoint of these guys. We'll draw the first one out so you can see what it looks like. Here we have 2, 7 and negative 6, 3. So this is the segment that we have to cut in half this way. So we need to know this point and this slope. So we first of all find out what this slope is. 7 minus 3 is 4 over 2 minus 6 is 8, which is a slope of 1/2. So this guy has a slope of 1/2. Perpendicular to that is a slope of a negative 2 over 1. Good. Now let's find that point right there in the middle, which is the midpoint of these guys. 2 and negative 6 add up to a negative 4 divided by 2 is a negative 2. And the point is 7 plus 3 is 10 divided by 2 is 5. Negative 2, 5. So now we have this slope and this point. And if we use the point slope form, we'd go y minus 5 equals negative 2x plus 2. Like that, sticking in that x value, that y value, and writing it like that. If we were to use this form, we would write slope is negative 2 over 1, so we'd go 2x plus y. Notice this is the opposite sign of the sign that we have here, equals, and then stick in a negative 2 and a 5, and we get negative 4 plus 5 is a 1. There we go. Look at that. So that, or this is considered point slope form. The issue with this one, why this one is not as often left as the answer, is that notice that there are billions of points that we could stick in here for this negative 2, 5. Yeah, there are billions of different versions of this form for this exact one line. For standard form, it's pretty standardized. For y equals mx plus b form, slope intercept form, yeah, it's pretty much standardized. This one will be unique because y will be solved for by itself. All right, let's try a couple of those other guys. Number 26. So we've got to find the perpendicular. So first we've got to find the slope. So negative 3 minus 7 is negative 10. Negative 6 minus 6, that's negative 12. So the slope between these 2 points is positive 5/6. So we want the slope to be negative 6/5. That's perpendicular slope. Then we've got to find the midpoint between these two. 6 and negative 6 average to 0, and 7 and negative 3 average to 2. Let's make sure we're okay with that. 6 plus a negative 6 is 0, divided by 2 is 0. And 7 plus a negative 3 is 4, divided by 2 is 2. So we're writing out the equation of the line that has this slope and this point. So if we do standard form, that's my favorite, 6x plus 5y equals, and then stick in 0 and 2, and it has to equal the number 10. And if we stick in this guy over here, it's y minus 2 equals negative 6/5 x minus 0. So like that. And you can see that this will give us an easy way to look at this one, which is y equals negative 6/5 x plus 2. And yeah, it went through 0, 2. That's the y-intercept. So that's slope-intercept right there. Good. Number 24. First of all, the slope here is 3 minus a minus 7 is 10. Negative 4 minus 5 is a negative 9. Negative 10 ninths. We don't want that one. We want perpendicular slope, so we want the slope to be a positive 9 tenths. And the point we need, negative 7 plus 3 is a negative 4 divided by 2 is a negative 2. And 5 plus a negative 4 is 1 divided by 2 is 1/2. Oh yeah, so we have, if we stick this in to slope, point slope form, we get y plus 2 equals 9/10 x minus 1/2. And then we could simplify it down to y equals mx plus b if we so chose. Alrighty, number 28. 9, 1 and negative 4, 1. So the slope on this is, we have 1 minus 1 is 0 over negative 4 minus 9. That's a negative 13. Notice the slope is 0. This is a horizontal line, so perpendicular to it would be slope of undefined. Oh boy, so this means our answer is going to be x equals a number. Let's keep that in mind. Undefined slope is straight up vertical like this. So we would be x equals a number, which kind of makes sense. This equation is going to be y equals 1. See how the y stays consistent as 1? So let's find the midpoint now. 1 minus 1 is 1 plus 1 divided by 2 is 1. Well, yeah, we better go through that. 9 plus a negative 4 is 5. Divided by 2 is 5 halves. So this is going to be the line x equals 5 halves. And just so you can see that on a graph, we should put that on there. We have 9, 1 and negative 4, 1. And here's the segment that we're trying to cut in half. And so we found the midpoint was this guy right here, and which is 2 1/2, 1, 5 halves, 1. And we're cutting him right in half like that. So this is the line x equals 5 halves. All right, number 29. 9 minus 3 is 6, and negative 4 minus 6 is a negative 10. So this is a negative 3/5. So we've got to get a positive 5/3. Let's put that over here, positive 5/3. And let's find the point that we're going through. 6 plus 3 is 12, divided by 2 is 6. That'll be the y coordinate. 6 plus a negative 4 is positive 2, divided by 2 is 1. So we've got to write the equation of the line that has this slope and this point. Let's use my favorite one here. 5x minus 3y equals, and we get 5 minus 18 is a negative 13. And that's standard form. All right, and the last one we have is number 30. So number 30, slope on this guy is 13 minus 7 is 6, and 6 minus 2 is 8. It's a slope of 3/4, so perpendicular is a negative 4/3. And what's the point that's right in the middle of those guys? 13 plus 7 is 20, divided by 2 is 10. That's the midpoint. 6 plus a negative 2 is positive 4, divided by 2 is 2. There we go. Let's do point slope form, this third one over here, and we get y minus 10 equals negative 4/3 x minus 2. Okay, and if you wanted to simplify that, jump the negative 4/3 in, bring it over, you would have y equals mx plus b form. Okay, let's clear some stuff up and look at the last ones. All right, number 31. Notice what we're doing, finding the distance from the following points and the following lines. So, or I should say to the following lines. So we're going to have a line. We'll graph number 31 to make sure we see what's going on here. We got 2x plus 3y equals 7. So if we were to graph this line, this is the x-intercept looks to be about 7 halves, and the y-intercept looks to be about 7/3. And so this looks like that line right there. Good. And we have the point 9, 5 is somewhere up here. So we've got to find wherever it hits perpendicularly and then find this distance by doing a squared plus b squared equals c squared. That's going to be kind of tough. So this is how it's going to work. We've got this guy has a slope of a negative 2/3. So we need to find the equation of the line that has slope is 3 halves and goes through the point 9, 5. So since we've written so many of these, we know, hey, it's going to be 3x minus 2y equals, and then 27 minus 10 is 17. Now notice what we have. We have an equation of this line coming right down through there. I'll put that in purple so you can see that. 3x minus 2y equals 17. And the blue one is this guy, 2x plus 3y equals 7. So now we need to bring these two together and find that point right there. So what is this? Let me see. This is systems of equations. We can times the top one by a 3 and the bottom one by a 2. So we get 9x plus 4x is 13x. Negative 6y and 6y gone. 51 plus 14 is 65. So x equals 5. So if x equals 5, we stick this in. That's the point here, 5. We stick this in. 2 times 5 is 10 plus 3y equals 7. Subtract the 10 and we get 3y equals negative 3, y equals negative 1. Ah, so my graph is a little off. It actually came through about like that, and there's the point. Okay, so 5, negative 1 is the point on both of these. So now we have to find the distance between that one and this one. So the distance from negative 1 to 5 is 6, and the distance from 5 to 9 is 4. So we get 6 squared plus 4 squared equals the distance squared. And 36 plus 16 is 52. 52 square root, that's going to be our distance. This one is 4 times 13, so we get 2 square roots of 13. Whew, these guys are kind of involved in that sense, aren't they? So we have to find the equation of the line that goes down through here, see where it intersects. Once we see where it intersects, then we can find that point and get the distance between them like that. All right, let's do number 32. So here we have slope of negative 3/4. So we really want slope of positive 4/3, and it goes through the point 17, negative 1. Okay, that's good. We could do that. 4x minus 3y equals 68 plus 3 is 71. And we're going to intersect that with y equals negative 3/4 x minus 7. All right, this looks like a substitution one where that'll go right up in there. 4x minus 3 times negative 3/4 x minus 7 equals 71. Let's jump this guy in. So we get 4x plus 9/4 x plus 21 equals 71. Okay, good. Subtract the 21 over and we get 50 on the right hand side. This is 16/4 x plus 9/4 x is 25/4 x equals 50. So if we divide both sides by 25/4, we get x equals, let's see, divide by 25 is 2 times by 4 is 8. So x is 8. Now let's stick that back in somewhere. If we put an 8 in here, negative 3/4 times 8 is negative 6 minus 7 is a negative 13. Whew. Alrighty, now we've got to find the distance between these guys. This is a distance of 12, and this is a distance of 9. So we have 9 squared plus 12 squared equals distance squared. Hey, that's a Pythagorean triple, 9, 12, 15. But let's double check just to make sure. This is 81 plus 220 plus 144 is 225, which is d squared. D equals 15. Holy cow, that turned out to be a distance right there of exactly 15. I'm going to write that down. That was pretty cool. Number 33. We have 5x minus 2y, so this slope is 5 halves. So if we have the slope of 5 halves, we want the slope of negative 2/5 to come in perpendicular to that line. And we've got to have the point 8, negative 4. So this gives us 2x plus 5y equals 16 minus 20 is a negative 4. And we're trying to cross that with 5x minus 2y equals 77. Let me see. Looks like we can times the top guy by a 2 and the bottom one guy a 5. And that will eliminate the y's. So we get 4x plus 25x is 29x. Oh boy. Those guys are gone. And then we get negative 8 plus, what is that, 385? I better get my calculator out just to make sure I don't mess it up. 77 times 5 minus 8, 377. 377. Oh, I hope this comes out nice. Divided by 29. Oh, it does indeed. That's nice. X equals a 13. So let's stick that guy right back up into the first one here, 13. We get 2 times 13 is 26 plus 5y equals a negative 4. Subtract that over, you get 5y equals negative 30, so y equals a negative 6. All right, so we're taking the distance between 8, negative 4, which is off of this line, and the line where those guys intersect is at 13, negative 6. Let's graph this. It's a little bit too much to keep in my head all at once. So 5x minus 2y equaling 77. We got to zoom out a long way. And so it's the x-intercept looks to be around, well, it's pretty big out here at like almost 15. And the y-intercept is actually way down here. It looks like about negative 34. And yeah, this has a positive 5/2 slope. And we're looking for where the point, so about 8, negative 4, somewhere around in here. So we've got to find one that comes in perpendicular like that. Ta-da! And then we're finding this distance. So the top equation is this equation of this line right here. Yeah. And then we're intersecting them. We found this point to be 13, negative 6. And so this guy right here, this is the distance now that we're finding. All right, let's do it. So the distance from here is 2, and the distance from here is 5. And you can see that right here. So we got a 2 and a 5. So 2 squared plus 5 squared equals the distance squared. So 4 plus 25 is 29, and square root it. So this guy is just going to be the square root of 29. Good deal. All right, number 34. This has slope 5/7. That's easy to see. So we need a slope coming perpendicular through this point of negative 7/5. And the point is 12, 1. So write the equation of the line, and we get 7x plus 5y equals, stick this in, we get 84 plus 5 is 89. So we are going to intersect that with y equals 5/7 x plus 3. Alrighty, looks like a good thing for substitution. Stick that guy right in. And we get 7x plus 5 times 5/7 x plus 3 equals 89. Jump this guy in. We get 7x plus 5 25/7 x plus 15 equals 89. Subtract the 15 over there, and we get 74 equals, and this is 7x plus 25/7 x. So this is 49/7 x. So we get 74/7 x equals 74. When we divide off by the 74 and times by the 7, we get x equals 7. So let's stick this guy up in here. Well, right back in here would work. Either one of these lines, because we're finding the point of intersection. So we've got, let me put this guy over here, 7. And then we stick him back over in here. 5/7 times 7 would give us 5 plus 3 is 8. All right, so we have a distance of 5. We have a distance of 7. So 5 squared plus 7 squared equals our distance squared. 25 plus 49 is, what is that? 74. That's what we got. 74 equals d squared. So square root that. Does that simplify at all? Let me see. That's 2 times 37. Nope. Square root of 74. There we have it. All right, number 35. All right, number 35. Here we have x minus 6y equals negative 2. This slope is going to be a negative 1/6. So we've got to worry about a slope of positive 6 over 1 going through the point 0, 12. Okay, so this would be 6x minus y equals negative 12. And we're going to now cross that line. This is the perpendicular one coming through that point. Cross that line with this guy, x plus 6y equals a negative 2. All right, let's try it. If we add these together, multiplying the top one by 6, we get 12x plus x. We get 36 plus 1 is 37x equals, and this is negative 72, and then minus 2 is a negative 74. That gives us x equals a negative 2. If we stick this over here, we get negative 2 plus 6y equals negative 2. Add that, 6y equals 0, y equals 0. So we get the point negative 2, 0. Okay, so, this will be a nice one. We have 2 and 12. 2 squared plus 12 squared equals our distance squared between these 2 points. This is where the 2 lines intersected. That's the point we're interested in. So we get 4 plus 144. That's 148 equals d squared. Sorry, squared there. And so we square root both sides. There we go. Square root of 148. Looks like this will have a 4 go into it. Yeah, so that will go in how many times? 37 times. So we get 4 times 37, or 2 square roots of 37 when we take the square root of 4. All right, so there's number 35. Now number 36. This has a slope of, again, negative 1/6. So we're going to use a slope of 6 over 1 to be perpendicular to it and go through this point, negative 3, negative 5. All right, so this is 6x minus y equals negative 18 plus 5 is a negative 13. Okay, that's good. And we've now got this line coming in and that line intersect them. We have x plus 6y equals 4. Let me see. Multiply the top one by 6 and we'll eliminate the y's. We get 36 plus 1 is 37x. And we get negative 78 plus 4 is a negative 74. Hey, look at that. It's just what we had up there. X equals a negative 2. That's handy. So the negative 2 goes right in here. We get negative 12 minus y equals negative 13. Negative y equals a negative 1. Y equals a 1. Oh, good. Glad that came out right. Negative 2, 1. Negative 2, 1. And this one. So we're finding the distance between these 2 points now. So 1 to negative 5, that's a 6, so we'll have 6 squared. Negative 2 to negative 3, that's a 1, so we'll have 1 squared equals our distance squared. And 36 plus 1, that's 37, and square root it. There's our distance for number 36. Good.